Hey students, we got lesson 11-2 here, multiplying and dividing rational expressions. We're going to learn how to multiply and divide rational expressions and how to simplify complex fractions. Go ahead and do the vocab. You can check back with your answers. All right, so here we're just multiplying, and remember, to multiply fractions, all you do is multiply the numerators together, multiply the denominators together. One thing I'll just tell you quickly here is that if you have a common factor in the numerator and denominator, you can cancel those. So just an example, let's say I have 3 times, well, let's say I have 3/9. The common factor there is 3. And that 3 cancels, so it simplifies to 1/3. We're going to be using that idea. Okay, so what is the product? 3 divided by x times -2 divided by x squared. So we're just going to multiply the numerators together. That gives us -6. And we're going to multiply the denominators together. And that gives us x to the 3rd. And there were no common factors to cancel, so that's my answer, -6 over x to the 3rd. We may just want to point out that x cannot equal 0 because you can't divide by 0. The second product, we have x times x minus 2. So we can write it like that, over x, the quantity x plus 3 times the quantity x plus 5. And that would be our answer. We could point out that x cannot equal -3 because we can't divide by 0. And also x cannot equal -5 if we wanted to. And if you wanted to expand those, you could. You could make it x squared minus 2x, but you don't really have to do that. And then on the bottom you would get x squared plus 8x plus 15. All right, I'll let you try one of those. You can check back with your answers. Okay, sometimes there's going to be a common factor that we can cancel out, and this problem will demonstrate that. So let me make it a little bit bigger here so I can work with that. First thing we want to do when I rewrite this is factor it. So 4x minus 8 has a common factor of 4. So I'm going to write that as 4 times the quantity x minus 2. X minus 2 can't be factored, but this trinomial can be factored. We need two numbers that have a product of 3 and a sum of 4. And that would be 3 and 1. So that would be x plus 3 times quantity x plus 1. And now we can see that we have some common factors. We have a common factor there. We're going to cancel those. And a common factor there. Going to cancel those. And when we multiply now, we really have 1 on the top in both places. So 1 times 1 is 1. And on the bottom, we have 4 times the quantity x plus 3. Now, if we need to point out what x cannot equal, we have to go back to our original equation, and we have to say here, x, it would be undefined when x equals 2. Maybe I want to write that a different way. This will be undefined when x is 2, x is -3, and x is -1. I think that's enough of pointing out where it's undefined. From now on, I'm not going to point that out, but just always remember you can't divide by 0. Go ahead and try this problem. You can check back with the answer. All right, Sometimes we may just want to multiply some rational expression by a polynomial. Well, just remember that that polynomial can be represented as a fraction with 1 as the denominator. So what I have is 3x plus 4 over 3x minus 9 times x squared plus 5x minus 24 over 1. Now I'm going to rewrite this by factoring everything I can, so I can see if there's any common factors. 3x minus 9 can be factored as a common factor of 3 in those two terms. X squared plus 5x minus 24, is there some number that has a product of negative 24 and a sum of positive 5? And there is. 8 and negative 3. So I'm going to do x plus 8, x minus 3 over 1. Now I'm going to look for common factors. And I see this common factor, x minus 3. So I'm going to multiply on the numerator. I'm going to have x plus 4 and multiply that by the quantity x plus 8. And then on the denominator, I just have 3 times 1, which is 3. All right, go ahead, you try that. All right, dividing. Remember actually this is the definition of division. That A divided by B is equal to A times 1 over B. In other words, to divide, we can multiply by the reciprocal. So that's the idea we're going to use here. So I'm just going to rewrite this division problem as a multiplication problem using the reciprocal times, and I'm just going to, the reciprocal of the quantity x plus 6 divided by the quantity x squared plus 5x minus 14 is x squared plus 5x minus 14 divided by the quantity of x plus 6. Now I'm going to factor. X squared minus 36 is the difference of two squares, so that will factor into two binomials, x minus 6 times quantity x plus 6, and the denominator 9x minus 18 has a factor of 9, and that gives me x minus 2. Then here I need two numbers that have a product of negative 14 and the sum of 5, and I think that would be 7 and negative 2. Now I'm going to look for common factors that I can cancel. 1 there, 1 there, 1 there, and that's it. So my final quotient is x minus 6 times the quantity x plus 7 divided by 9. All right, I'll let you try one of those. Notice a little mistake there. They said that was x plus 1, that was supposed to be x plus y. That was canceled. All right, one more problem here, dividing a rational expression by a polynomial. That, again, we're going to use the definition of division, where dividing by some number is the same as multiplying by the reciprocal. So just to give you a quick example, let's say I was dividing the fraction 1/2 by 3. Well, what I would do is just do 1/2 times 1/3 to do that, which is 1/6. So that's what I'm going to do here. I'm just going to take 8x to the third minus 8x over 4x, and I'm going to multiply by the reciprocal of the quantity x squared plus 5x plus 4, which is 1 over the quantity x squared plus 5x plus 4. And now I'm going to factor. I can factor out an 8x, and that leaves me with x squared minus 1. And I want to factor completely. That's the difference of two squares, so that can actually factor to x minus 1 times the quantity x plus 1. Alright, and then I have 4x there. And then over here, is there two numbers that have a product of 4 and a sum of 5? And there are. X plus 4 times quantity x plus 1. And cancel that. 4 goes into 8 twice, so there's a factor of 4 I can't cancel there. And then the x I can cancel. And now I'm left with 2 times the quantity x minus 1 times 1 in the numerator, and x plus 4 in the denominator. Alright, go ahead, you try that. This problem didn't show up in your packet, so I will give you an extra pop sticker if you write this down and go through the work showing how to do it. Alright. 19, 20, and 21. Go ahead and see if you can figure those out. You can check back with your... Alright, problem 6. We're going to just think of a complex fraction as a division problem. So what we have is this fraction, 1 over x, the quantity x plus 4 divided by the fraction x minus 3 divided by the quantity x squared minus 16. Then we're just going to change that to multiplication by multiplying by the reciprocal. Then we are going to factor what we can, which is the x squared minus 16. That's the difference of two squares. So that would be x minus 4 times the quantity x plus 4. And then cancel the common factors and simplify, and we get 1 times x minus 4 over x minus 3. Alright, you try that. And the lesson check. Go ahead and do that. I'll give you the answers and then we'll call it a lesson. Alright, there you go. I'll see you tomorrow.